Igneous rocks. First, I want to say that the cool part of rocks is the hands-on part. And that is on the reader's exam, the Part D or Lab Practical, where you actually have to identify real rocks. I have videos on how to identify rocks for that, so make sure you watch those. This here is a little more of the information behind rocks and using the reference table to answer questions on the written part of the exam. So here we go. First, rocks are composed of minerals, and there are three types of rocks, which you probably know by now. It's igneous, sedimentary, metamorphic, and here we're looking at igneous. Here we go. So igneous rocks form from the cooling and solidification of molten rock. And molten rock, the word molten means liquid. So we're talking about liquid rock. You may know of lava, for instance. That is igneous rocks, forming from volcanoes on a basic level. So, and this is page 6 of the reference. Here's the rock cycle from the cooling and solidification of molten rock. So here, magma to igneous rock solidification. That's key. We'll get back to this. So igneous rocks are, again, from the cooling and solidification of molten rock. And liquid rock, really, we classify it, we're getting more detailed here, two separate ways. Lava is liquid rock on Earth's surface. And if it's underground, it's called magma. And that's liquid rock underground. Igneous rocks, we classify them based on their texture and the mineral composition. Please, I want to say texture. We don't mean rough or smooth. Don't say rough or smooth for texture if you ever have to write in an answer. That's not what we mean. It's more complicated than that. So here are some igneous textures. Glassy, vesicular texture, which has gas pockets, and then fine, coarse, and very coarse. These here, actually, these are lava on the surface that cool quickly. As a matter of fact, these cool quickly. As we go down here, it takes longer and longer and longer time to cool. And now it can be in the thousands of years for rocks down in the very coarse to cool. So let's look at the chart. This is on page 6 of the reference table. And this is the igneous rock chart here. So let's look at some of the textures. Textures are here. So I'm zooming in a bit, and the glassy texture, it says glassy, are all of these rocks, obsidian, pumice, basaltic glass, and scoria, are all considered to be glassy. Here's an example of glassy. And if you probably, geez, I hope you saw this in class. I hope your teacher showed this to you because it's really cool. Everyone loves glassy igneous rocks. It is very cool. But this cooled lava that cools very quickly, that causes it to have that glassy texture. Vesicular textures, gas pockets, like little holes in it. It looks kind of like a sponge, and that also cools really quickly. That there's gas bubbles that are in the lava that don't have a chance to escape, and it kind of cools very quickly, and those holes are in the rock itself. So vesicular rocks with vesicular texture are pumice, vesicular rhyolite, vesicular andesite, vesicular basalt, and scoria. And let's look at some pictures of it here, hopefully to ring a bell. Vesicular texture, gas pockets, those little holes, again, very much like a sponge. This is another one. And this picture of pumice, you can see has a sort of different holes. These are usually really, really low density when you hold them in your hand. Kids often say, I can't believe this is a rock. So these are photos of them. These are from readers' exams, how it's represented in diagrams. They show it here really well. This, a little harder to see, but I think it said it there. It told you it's vesicular texture. But so that is key to know as well. This is also lava that cooled quickly. Now we're getting into lava that takes longer time to cool. Actually, some of it's lava, a lot of it will be underground magma. It takes much longer to cool if it's underground. So this will show cooling from stage 1 to stage 2 to stage 3. So here all the white is all liquid. This is the first mineral to solidify and form, and then more are forming around it. This is still liquid, and then these gray ones here are the last, and they will fill in. And therefore it gives you, when it is solidified into a rock, you have this, we often say, angular interlocking crystals that are random and not in an order or pattern. Okay, that is key. We'll get back to that as well. So the igneous texture, the crystalline texture, where crystals actually formed, you have fine, coarse, and very coarse, an increasing cooling time. Okay, so these cooled faster. These took a longer time to cool. Again, into the thousands and tens of thousands of years if it's deep underground, which is crazy. Okay, key fact: the longer molten rocks. Longer molten rock takes to cool and solidify, the larger the crystals will be. So if you see very large crystals, it took a really long time to cool, and therefore it cooled underground. Make sure you know that. So this would be a rock that has fine texture. Here you can't really see the mineral crystals. And then these are our fine texture rocks here, and they're things like basalt, andesite, rhyolite, and some of these, there's some overlap with vesicular rocks as well, but and a little, some of the diabase is kind of in between there. So that's where you find that on the reference table. And then coarse texture looks at this. This piece here is probably about the size of a softball. So, and then this here, what I have is, this is a close-up of this rock here that I got in Barry, Vermont. Okay, they call it granite. And it is a type of granite. And this, I have a scale in there of a penny. So these are the crystals here. Let's zoom in a bit. So this is the edge of the penny, and you can see this is actually going to be, again, coarse texture. And you can see the crystals here, and then you can see one here too, the edge of the penny. You see the angular interlocking crystals that are randomly placed. There's no order or no pattern to it. So that's cool. And then this is where we see the coarse rocks on the reference table, and there's a bunch of them: dunite, peridotite, gabbro, diorite, granite. Okay, that's the coarse texture. And these are usually mineral crystals you can see with the naked eye. Fine, you usually can't see these with the naked eye at all. It doesn't look like much. And then very coarse, again, this may be the size of a softball. Now you're starting to see mineral crystals that can be, up to this big, which is really large for a mineral crystal. And then the very coarse texture, really the one that we really see is pegmatite, okay? And that it has here, so that's basically 1 centimeter or larger, the mineral crystals, or larger. So this cooled very slowly, took a long time to cool and solidify deep underground. And then this is a close-up of it. So one thing, igneous rocks have interlocking crystals that are random, okay? Here's an example of one here. Here's another one here, angular interlocking crystals that are randomly placed. And then here's that other one I showed before, angular interlocking crystals that are random. Key. This, funny enough, is how they represent igneous rocks on one of the Regents exams. This is how they drew it. You may see this, maybe less so now. Kind of crazy. To me, it looks like a big ball of like chewed up gum they put together, but just that's how they're trying to represent that. It is hard to draw. They've gotten better over the years. So the other thing I want to point out, on the reference table itself, so we were looking at this chart here, the mineral chart's at the bottom. It's really cool how this works. So one thing I want to point out is that on the left side, these are the minerals that sort of make up the rocks that are on the left side of the chart. Potassium feldspar, quartz, pelagic feldspar, some biotite, and amphibole. So these are like your black minerals, and this is like pinkish, white, and these are your like lighter color minerals. And so this is basically a light color rock with a lot of that pinkish potassium feldspar in it. As you move towards the center, this rock here has a little more of like much more black, more of this sort of whitish gray. So it's more of this almost half and half black and white look. And as you go this way, they're getting darker in color. And so this would be something like gabbro or basalt that's going to be darker with these really dark green minerals here. So that's one way that this chart works, which is kind of cool. The other thing I want to point, so this here, so we were just dealing with color, darker on this side, lighter on this side. Density, these are lower density rocks. These are higher density rocks. You can't really notice, this may be 2.7 and 3.0, so it's not like you can feel it and tell. I don't mean that. And then composition, we say that these over here, these are made of minerals that have a lot of silicon and aluminum. They refer to it as being felsic. And then as you go this way, these rocks over here are more, we call the term we use is mafic, and they have more of the element iron and magnesium in it, causing them to be dark. So this is often a key part to any questions on igneous rocks, and using this compared to this. So there can be a lot to this. So for instance, this is a fine-grained dark colored igneous rock is most likely, and it's referring to this here. Okay, this is igneous intrusion, and basically, so it's a fine-grained, dark-colored igneous rock. You have 4 choices. Let's look how we find this out. Fine-grained is going to be here, so it's going to be one of these, and it's going to be dark, so it's going to be on this side of the chart. So it's really going to be diabase basalt or vesicular basalt. So one of those our choices, because again, darker over here, and so basalt is our answer.